Okay, this is part 2 of the video tutorial. I just didn't have enough time to do question G beforehand. So the last question is a excess reagent question, and it says calculate the volume of 1 molar sulfuric acid which would be added to the remaining excess reagent in order to neutralize it. So to do this question you need to do several steps. It's quite a complicated question compared to the other ones. The first thing you need to do is determine the moles of the excess reagent and the identity of the excess reagent. So you know that the limiting reagent was phosphoric acid, so you can determine that the excess reagent is calcium carbonate in this scenario. So calcium carbonate is a base, and therefore it would be neutralized with an acid like sulfuric acid. And even though I've put this as the second step here, it's probably better to write your reaction equation for this reaction first so that you know what you're dealing with later. So it's going to be neutralized in a neutralization reaction. So when an acid and a weak base combine together, they produce carbon dioxide, water, and a metal salt, calcium sulfate in this case. And then you need to make sure that this reaction equation is balanced. So this one actually is. Just make sure in your own head that you understand how it is balanced. So it doesn't need any coefficients at all. Everything is produced in a 1-to-1 ratio and reacts in a 1-to-1 ratio. So the first thing you need to do is determine the moles of the excess reagent. And the way to do that is to use the previous reaction equation and look at the reaction coefficients. So let's do that. So in this reaction, 3 moles of calcium carbonate are required to react with 2 moles of phosphoric acid, which means that you should determine the amount of calcium carbonate that's reacted. You would go 3/2 times by the moles of the limiting reagent, phosphoric acid, which once again gives us that same moles of 0.18 moles of calcium carbonate, which has actually reacted. Now, in an earlier question, we calculated the amount of calcium carbonate which we had in total, which was 0.319 moles. You're going to remove the amount reacted to get the amount remaining. So that is 0.319 minus 0.18 to get 0.139 moles remaining. Once you've determined the amount remaining, you know the amount that must be reacted with sulfuric acid. So in order to determine the moles of sulfuric acid which are required, you're going to have to use the reaction equation. And as said earlier, these react in a 1-to-1 ratio, 1 sulfuric acid for 1 calcium carbonate, which means the same moles of sulfuric acid will be required, 0.139 moles. The last step is to convert that into a volume because you have the concentration of the sulfuric acid, and you need to find the volume which will supply that amount of sulfuric acid. So you're going to use N equals CV. Your moles are 139, sorry. Your concentration is 1.5 molar, and you're solving for volume, which gives you 0.093 litres. Convert this into millilitres because that's a more sort of realistic volume that you're going to tell somebody. And this should be given in significant figures, so 93.0, but it's 93 mils. I hope this helps, and good luck, everybody.